Welcome to a new test and teardown video. Well, I think this is going to be more a teardown than a test video, because this HP 431C power meter, I don't have the probe. Just too bad, but I got the manual. Anyway, I just found this in the junk box the other day, so I might as well check. Is this the one with the battery option? Anyway, I think we should be able to put some resistors between pin 1 and pin 2 and at least make it go to 0 in case this instrument works, because it's actually just measuring NCC resistors and their individual change in resistance depending on the power you put into a one of them, and the other one is of course the temperature reference of the probe. So that's basically how it works, measuring power by heating up the sense resistor. There is something that rattles around inside this unit, so I guess somebody's thrown it into the junk bin. So that is why I need to open it. I can't just power it up. So let's do that and see what is the loose part. So now it's open, and I did find some loose items. Those two screws. Like that. And maybe that will be some of the screws, probably for the battery. Maybe the battery goes in here somehow. I just can't see how you can do that really. So what do I need to open to access that? Probably the bottom. Yeah, okay. Didn't do that, so that'll be all the oscillators and power supplies and stuff. Ooh, one of the caps there is. That can't be good. There's a special color from that one. Okay. But else it looks quite alright. What? Yeah, I saw that pot. Can you see it's? Ooh, see if I hold this straight. So this is what happens when somebody is mad at stuff they throw out. So this one was definitely on its own little flying trip to the bin. Ooh, it's the whole plate here that's just, wow. But the pot looks like it's actually still intact. This entire plate is bent and the shafts rotate still quite alright. Oh, that is impressive. Okay, let me look at the calibration, all the different trimmers for calibration. That will be here. And there's a little temperature sensor in the middle of the picture there, right? So that will be an NCC as well. Or something like that. This is a very typical old style kind of how they looked. I think I will take away the bottom plate. Let's have a look. So this is the compartment for the battery. Look, you'll be able to fit a really big fat battery in here. And the mains transformer, look how tiny little it is. That's because we only got a few transistors here, and this unit is just running at 10 kilohertz. You see, this isn't really using just a few watts. That's kind of all there is to this. They're not cracked. So that is nice. Oh, look what I saw, by the way. See this pod? See, there is actually a shaft that went through and bended the back plate. And also, can you see the marks on the PCB? So that means this pot went all the way in and hammered on the PCB. Isn't that just something? So somebody was really, really angry with this instrument. And that is just how it goes sometimes. Let me see if the meter is... Yeah, it's okay. I could actually power it up and see if I got 10 kilohertz, because this thing is running at 10 kilohertz. And that's kind of all there is to this. Let's look at the rear side. Here we got the same connector. And since it is only 10 kilohertz, it's perfectly fine to mount the detector on the rear. Really a big, nasty, special connector. I'm not super happy about this tiny mains connector from the 60s and 70s. Whoops. Let's try and power it up and see if there's any kaboom left in this one. 2.6, 2.8 watts. And we got lamp. And there is, of course, no response on this one. We're not on the battery. Test. What is that testing? Ah, so it can charge the battery, and this is probably testing the battery voltage. And we are on the battery, and we are on. Okay, so far, so good. So the two pins on each side of this slot, that will be pin 1 and pin 2. So this is where I will try and put in a 100 ohm resistor, and we'll see what happens. See, look at that. So this is 100 ohm. And now comes the fun thing. Oops. That is not what I expected. Maybe it is that one. Yeah, okay, because I don't have the capacitors and stuff. Because the bridge is not just 100 ohm. I guess it's also some... Yeah, no. No, not really. But anyway... I believe it should be doing its thing here, but I'll take the scope and see if there's any 10 kilohertz then. I'm still laughing a little bit here. You gotta see this. I'm still browsing around this manual, and they're explaining how different, like, fundamental thing works, so you'll be able to understand and read the manual. I mean, seriously, if you don't understand the basic fundamentals of, like, NPN transistors, PNP transistors, I don't know, why do you need to understand vacuum tubes? There isn't really any vacuum tubes inside this unit. This is so cool. But at least here you can learn how the cutoff and conducting part is working of a, I don't know, why? Don't read this manual if you don't have the fundamentals. Isn't this is just amazing. Oh, let's just talk about the basic transistor couplings. I am still a little bit in shock about this. I'm so sorry, but anyway, please read this manual and learn a little bit about transistors. Yeah. Let's look a little bit more about how this truly works, because on the other page they only show the RF detector part of it, and they don't really show the pins and the connections and what is actually going on. But so that will be my 100 ohm that I will put between pin 1 and pin 2, and that seems to have an effect on the meter, but I can't zero it, so that means something else is wrong. So of course I also need to put the compensating thermistors. They're measuring the ambient temperature, and that is of course needed, because if there is no power applied, the ambient temperature will also be on the detection thermistors. So if those resistors, they follow the same temperature rise here, then you of course don't see anything on the meter. So that is the whole idea, right? And if all this works, I should be able to dial the zero. This is at least how I figure out I should be able to test if this unit is working or not, right? So pin 1 and pin 2, that will be the RF detection, and this will be my ambient temperature sensors, and that will be between 4 and 3. So far, so good. So this is what I've done. I've been looking around on the bottom side, see? And that will be 1, 2, 3, 4, 5. So one resistor is 1 and 2, and the other one is 3 and 4. But unfortunately, it just don't work. I'm sorry this is upside down, but it will be the same result. The result is not so good. Because, see? There is no zero. So there's probably something more wrong with this. No matter what I do. Why is it doing that? Yeah, they are connected. Yeah. That is not so good. Or maybe I didn't understand the interface here correctly, so I'll have to look a little bit more. I have now tried everything, including this little detail here. Is the ground. It looks a little bit like this one is also connected to pin 4. I guess. You can't really know exactly, because you can also see some capacitors here, and they didn't really draw any capacitors here. Maybe they're not, and yeah, I think those capacitors, they could be like 2 nanofarad. This is also what I've seen in the other sheet. But are they connected like this, or is that, how is it supposed to be? But anyway, I don't get any kind of response on any of these two, so that means I can't zero it in any way. Because of the mechanical stress this pot meter kind of experience, of course I'm checking. See? So that'll be the pot. And both of them, they actually work, so yeah. So there's a reason why they trashed this. They really gave up. And there's also a broken zero trim here. But the meter is actually really well trimmed. So that means we don't need to be sad about that. So, and also I tried the different capacitor values here to see if this had any effect. So I should be able to trim it in, and that is not the case. Let me remove those again, and let's turn this on again, and you'll see the meter is quite stable here. But if I go to other ranges, it behaves like this, and that I don't like. So there's some sort of a weak leak, or some stuff is not working. This can't be good. You see? Yeah. I think this is going to go back into the shed with a whole lot of other stuff that is just not easy to figure out if it works or not. Maybe one day I find a probe or not. Or if you own an instrument exactly like this and you know that it is working, can you please tell me exactly what kind of resistors I need to put, or capacitors, and how can I verify if my instrument is working or not? Please explain this in the comments, or paste a link so I can find this information real easy. Then I will be happy to take this back into the lab. But so far it is going back to the pile of stuff. So thank you for watching and have a good day.